a bachelor's degree in mechanical engineering and also electrical engineering. Bachelor's in mechanical is from Penn State, electrical engineering is from Lehigh University, and a master's in industrial engineering from Lehigh also, and robotics, that type of thing. Been in the career of engineering, licensed professional engineer for the last 45 years, and got into teaching at my end of my career for the last 6 years or so because I wanted to return basically my educational experiences and my work experiences into the classroom. I worked at many different places. I actually started out in AT&T. I was there for the integrated circuit manufacturing plant that they had in Allentown, Pennsylvania for 10 years. And then I went into consulting and worked at various companies in consulting. And my last was running in engineering offices, doing BAS consulting work, engineering consulting work, electrical, mechanical, and building design, basically. In my last portion of my career, I was in the commercial world since the late 90s. Was doing commissioning as a item inside our services, actually commodity. Then we actually commissioned, or I commissioned over almost 100 some buildings, lead buildings, and associated other buildings. The commissioning process is a very rigid process that looks at the building as a whole and how it functions. So we go through the basis design and then verify that actually installed that way. It has merit back into the process by making buildings that are designed but maybe not programmed correctly, finding those errors in the beginning of the lifetime of the building to save energy and to make indoor air quality requirements and that type of thing. It's a very good process of understanding different designs, of different engineering designs and different ways to approach building construction and building design. So, I mean, it fits in very well in that aspect, and it's very good on the experiences I have obtained to handle the teaching side of it for students that come through. I have a lot of practical experience for almost any HVAC design system. What are the good parts about it? What are the bad parts? You know, I always ask the students, kind of like, if you were the designer, you had your blank canvas, and what kind of system would you put in here? Would you put a water source heat pump in, or what kind of system would you choose, and why would you choose that? And then how are you going to test it after it's installed, and how are you going to make sure it performs the way it's supposed to? There is a couple different avenues of basically commissioning. Just turning on the equipment is basically like startup commissioning. That is just basically ready check. The real commissioning process is working through and verifying all the basis design and all the functionality of the system are interacting and working together. And it does go deeper than just mechanical. There's electrical commissioning, there is life safety commissioning, there's egress commissioning, vertical transportation commissioning. They all work together, and some smart buildings they're all integrated together work systems to work as a whole. So it's going more than just turning things on or just verifying that things are started up. Building commissioning started out in the BAS because of the complicated control systems that have been designed since the late 90s and on. We were starting to get buildings that are put together, designed correctly, but not installed correctly because the expertise wasn't there. And there was no verification that the building was actually performing the way it should be as the basis design at the start or the functionality of being occupied. Then the second thing comes along is a retro commissioning, where basically you go back in and commission the building again that might have not been commissioned in the beginning, but it's going to be commissioned at later on time frame. And then there's recommissioning, where you go back in and actually redo the same commissioning process to day one, maybe 10 years later or 5 years later, to see if it's actually still performing the way it's supposed to. Now, every time you go in and do a building commission, through my whole career, I have never seen a building pass flying colors the first time. If you really do the commissioning correctly, there are problems in every building. And finding those problems, I always thought was the hardest part. But then I found out there is another hard part. And the other part is getting it corrected. Because correcting an issue doesn't mean that, oh, it's a simple, oh, they left something out, or they didn't put something in, or whatever, or something isn't turned on. A lot of times there's a conflict with the original design. And that takes a go back in and actually look at the design in the engineer's world and see where corrections can be done. And it might be re-engineered to actually make it function. The engineer had an intent on how the building is supposed to perform. They picked systems to put in there. Doesn't mean that those systems are going to work together nicely the first time. And that's where I take my expertise, because I understand how the systems, I've been in the design world for so long, and before doing commissioning, and actually is a licensed professional. So I would help out the engineer in many cases on, here's what I would suggest, but you're still a record engineer. I can't make those changes. They have to make the changes, but we work as a team to try to work it out, because the whole goal is basically have the building function like it's supposed to be intent. Really, the commissioning process should start with the owner's project requirements, or OPR. That is the most important document in the process, and that starts out at the very beginning, before even plans are done, even before drawings are even conceived, even before the architect actually really gets their feet on the ground. And the purpose of that document is, what is the building's purpose and the use? If you don't design if you don't have the use for the building down, understand, well, you're going to get a building, but it might not be what it's going to be intended to be used for, or what the owner thinks it's used for. And also the commissioning agent wants to see that document. The OPR document is important because during testing, a real commissioning agent will use that document to actually verify the test results. So if the building owner wants the room at 65 degrees year round, or in summer, and 85 in the wintertime, or wherever criteria is in the owner's project requirements, that's what I want to see when I do the testing as a commissioning agent. Then you get, basically from that point, you have the architect and the engineer get involved. They do a contract document set that's actually a biddable set for pricing and building. Doesn't mean it building's functions, it's basically get the material in the building to price and then build. So there's one handoff again. Functionality is kind of lost in that deal. So that's why the commissioning agent needs to be involved during the design process, because we keep bringing that back in. Commissioning agent needs to come back in and say, hey, how are these two systems supposed to function together? What's the sequence for this air handler? What's the sequence for that piece of equipment? Is the elevator supposed to go to the 5th floor when the car key access for such and such suite is done? Or is it supposed to go to the 7th floor? You need those criteria written down. Lots of documentation, lots of documentation. Then when it gets handed off to the contractor, first thing I always do is I bring in the control contractor and the HVAC contractor, and I sit them down. Lots of times they're a sub for the HVAC, but doesn't necessarily mean that there's a good relationship there. It just happens to be that's the winning guy that got the right number in at bid day. Okay, I bring them together and say, okay, here's the owner's project requirements. Here is a set of documents. This is what the design intent from the engineer was supposed to do. Any questions, Mr. Control? Any question, Mr. HVAC, or electrical contractor, or the whole gamut? Any questions this time before you even start building the building? Because we want to address these questions and concerns before you order the equipment and before you start building it. Because maybe just the way the combination of different manufacturers are put together, that one manufacturer, even though it's in the contract documents, won't work as a whole. And we're trying to get a holistic side of it. So there's another place where it gets dropped. Then the big question is the documentation from the contractor that goes into the building. Most contractors will wait until the end day, delivery of the building, to bring in the O&M, or the maintenance and operation manuals, the O&Ms, and hand them over. We want to see those first. We want to see those before you even order the piece of equipment. We want to want to see those manufacturer's documents, and then, because inside those items are important information on how to start the equipment, how to maintain the equipment, I want the building owner to understand where to find that information, how to do preventive maintenance on it. I want the equipment to run as the manufacturer's intent for many years later, not just, oh, hand it over and when you have a problem, go look in the manual and see if you can figure out what's wrong with it, okay? So there's another place where I always front load that into my designs and have that document there for when I turn it over to the owner, he has a complete set of O&Ms earmarked where the important things are. What do you do weekly? What do you do monthly? What do you do yearly? You know, how many times you do that kind of thing. And also at the very end, all the other documentation called the shop drawings, which is the instrument, you know, the drawings there, the startup reports, and all that piece of equipment, all in one book for that piece of equipment. So when the maintenance person comes onto the site or there, he has a place to look up for every piece of equipment in the building, and you get all the historical data. The second reason, or the last reason is, when you're going to do a recommission the building, you go to that document first, because there you want to verify what was put in first doesn't match what it is now. And lots of times you can find errors or find things that changed, drifted, whatever, and fix the building, tune it back up the way it was supposed to be originally built. In Delaware Tech, we have three major energy programs. One is energy management, BAS, and solar, or renewable energies, I should say, because it goes like deeper than just solar. Okay. So the BAS side of it is one of the last courses in the BAS after we go all the fundamentals and through there is we have an air handler in our lab that we actually I have to have the students work from the very beginning, just like the project. So if they get a set of documents from the, you know, bid documents, basically, they have to see those documents, they have to pull out a shop drawing list, they have to do a wiring diagram, they have to do a submittal, totally submittal. They can do the RFIs, the request for information submittal. They bring that in, I answer the RFIs and send them back, just like you have in the construction world. And then after they ask what questions they want or whatever, they put their wiring diagrams, that comes in as a shop drawing approval, just like in the real world. We take that and mark it up. And I have to do one or two versions of that, have the shop drawing approval. Once they get a shop drawing approval and they get approved it, then they can take a set of hardware and go into the lab with the unit, doesn't have any controls on it, and wire it up. And then program it, check it out, commission it, and then have it ready for checkout, final commissioning process at the end. That's the capstone course. So all the way in that whole process, we go through the whole the setup just like they'd be out in the real world in a construction site. First, they start out with a, we call it 140, which is a general course on how set of documents and how the building utilities and equipment are there, so they can see the interface between mechanical equipment and electrical and fire protection and life safety on drawings, how to read the drawings, how to understand sequence of operations and that type of thing. Where to find the information on a set of building drawings, okay? So that's where we kind of start with. Then we go into two courses that are built on top of each other, and that is doing the fundamentals on all the engineering information. So in other words, understanding pump hydronics, understanding HVAC, understanding pipe flow, losses in pipe, losses in engineering. So they understand basically basis of the engineering side to understand that, hey, these are the components, where they're in the system and how they function together. And that also kind of correlates with the electrical side. We have a separate course that essentially brings that also thought on, you know, what is the power factor, what is three-phase service, how that works together, how electric motors operate, what's the efficiency of electric motor. We do a number of things of doing wire to water, where you take basically power coming in from electricity into the motor, into the pump, into the water, and go through that whole calculation where the efficiencies are and that type of thing. So they have a very good understanding of how systems can work together. Then also, some of those courses, in the first courses also tail into our energy management side of it. It gets in a little bit deeper into looking for efficiencies. So their course, when they split a little bit, they'll go in and do a lot of data logging into our existing buildings that we have. And we know issues that are in the buildings. So they'll data log and look for what sequences aren't working or how energy is lost in the functionality of the building, type of thing, and then come up with energy conservation measures we call ECMs in there, and then provide that and do all the calculations on where the break-even point would be if they went through and replaced that, what they proposed to replace. If a boiler needs to be replaced, or an air handler, or say a pump is not running sequence-wise, they'll go through and do the calculations and see, oh, that will pay for itself in 3 years, 1 year, whatever, like that. And then they actually present that to the facility people as items that they should put on their list for preventive maintenance or replacement. We pick buildings on the campus and data log and look at the visual drawings, how they're supposed to be designed, what this original sequence is supposed to do. Is it doing that sequence? We go through the data logs and look at the historical data and pick out what we see repeating things that are happening. Maybe a pump's running when it's not supposed to be running on an unoccupied period, when it's running anyway, and that's wasting. And then we figure out, okay, how many hours is that pump running when it doesn't need to run because something wasn't sequenced right? And if we do take it off that sequence, well, that one's an easy cost-wise, because there isn't really it's just a little programming, but you save all the energy, and then they propose how much they would save.
Yeah. So your program has really good relations with your facilities department?
Mm-hmm. Yeah, they look forward to it as ideas on where to, they're conscious on trying to cut the budget on energy too. So they see a lot of our the students' proposed energy management measures to be, something they look into.
Yeah.
And it goes more than just, like Bob said, counting the lights, where, that was, say, 20 years ago, where efficiency, when going to LED lights, was the big thing and save energy. Now we got to look a little deeper than just those.
Right.
We have had recently grads that gone into the high 5 figures in, now they're, some come in with past experience and some historical, have more work history than others, but we're all in that, 50, 60,000 up to 100,000 range. We have kind of a mix. A lot of them, some go to the, or our BAS contractors or control contractors are definitely a big place. But some have gone back into the design world to being really knowledgeable how control systems supposed to work, because a lot of the engineering houses are weak in controls.
Yeah.
And I always, I always tell my students, and always told, always through my career, it doesn't matter what piece of equipment you buy, but if you don't turn it on or turn it off the right time, the client's not happy. It has to work together. The controls have to be working with the unit. You can have the best piece of unit, but see, you never turn it on, it's not going to satisfy the client. So, they have to go together. So you can be a real good selector and designer, but if you don't have the sequence there, it's not the full package. I have a few students that have gone in and actually aren't, they don't have an engineering degree, but they have a technician associate degree that the engineering house likes, because they can go out in the field and do some light commissioning or review shop drawings, control shop drawings, and have the knowledge of finding out, seeing that how you would install it and seeing errors where they could be corrected before they're installed, which is a big plus, because most of the time when the control shop drawings come into an engineering house, they don't have the expertise inside to really understand where the shortcomings are. And you want to find those shortcomings before it's actually installed. Later on in the game, it keeps getting more expensive to correct.
Yeah. And ultimately, the the engineering firm is responsible for the errors that are made by the BAS company. Is that
Yes,
right?
that's true.
If anyone can figure out where the errors are.
And plus, you have a client relationship. If you're in the engineering world, you have a client relationship. You want a no hassle, clean, functional building turned over to the owner without issues for the next, for your reputation. I mean, if you get a reputation that when you are the engineer on the job, the buildings get built and it's clean sailing, that helps your marketing.
Yeah, yeah. Talk a little bit about on the energy management side. Where are those students going to work?
A lot of them just get into industry. Industry is loving some professionals that can go in and look at existing processes and hunt out where the shortnesses are. So that's what we're actually training. I mean, they can go into the building and start saying, "Hey, we seem to be losing a lot of energy in this one process. What can we change to do it? And then what is the ramifications to do so? And what is my break even? What's the economics of it to sell to the upper management to do that project?"
So who are they actually working for?
They're actually working for the different clients, the different industry or different building owners.
Oh, okay. So they're
Or in the consulting world.
What kind of salaries are they receiving?
They're about equal, not quite as much as the VAS, but we're close.
Mm-hmm.
Yeah. I believe the new trends are really on more being able to model these controls and the building operation before the building is actually built. So you can see how how everything works together and function as a whole. We're getting a lot better modeling systems, a lot better in basically artificial intelligence is kind of kicking in a little bit, and we're getting a lot of, I think that's where the future is going to be. Well, we're always updating the lesson plans.
Uh-huh.
I mean, it's like, that's what I do from once a course is over that semester. The next semester, I'm updating it. Between the two, I'm updating the lesson plans for the next semester to keep them up to date, because we're in it's like they're always changing. There's always something different out there to improve. I mean, the big talk right now is all decarbonization. So that's changed the whole thinking of what systems to put in. The fossil fuel systems that were maybe 5 or 6, 10 years ago would have been a no-brainer. If you had utility out on the road, you had gas in. But now you think, no, now we got to do something different. The renewable energy sources are getting a real kick, and how they dovetail together into the system. And then you start looking at, to keep the duck curve issue, where if it's heavily on solar renewable, that's only during the day. So how are we going to move some of these loads in the evening? Where back in the day, we were actually, save it until you need it and generate it then. Now we're thinking, how can we basically generate it at a different time of day, instead of nighttime during the day, but we need it at night, so. My state, Delaware, is getting more and more aggressive in that way. They're doing a lot more on transportation, EV. They have come through and gone with the California side of it, where we're, in 2035, we're not going to sell any more fossil fuel burning, carbon emitting cars, zero emissions side of it. So we're doing the same thing. They're working in that way, same way as the buildings, not anything legislation I know of right now in the buildings, but it's definitely going that direction.
So does that mean that as a building technician, I'm going to have to start thinking about all these electric vehicles that are charging in my building parking lot, and I've got to manage that load along with other loads the building is generating?
Yes. We actually, in, say, Delaware, they can get a very hefty rebate. I mean, almost like 90+% of the charging station, installing a charging station in industry back from the state. So it's pretty much not a dollar restricted area to put a charging station in on in from any company wise. It's the infrastructure doesn't support it. So actually on our campus right now, we have a couple charging stations and we really need probably 3 times as many as we have, and it's not the cost of putting the station in physically, it's the cost of putting the infrastructure in for the station. We're maxed out in locations where it is, which makes sometimes a creative, if you're an EV driver, a creative way to try to get there before the next person, or obviously Monday morning is always a problem because every time everybody uses it over the weekend and goes to work with a very low supply in their car. And it's who can get to the charging station first gets the, maybe the first 3 or 4 hours. And then we have a kind of a lottery on who gets the next 3 or 4 hours. So it's becoming a slight touchy area.
And ultimately, you'll have to upgrade your electrical system on the campus to accommodate
Yes.
in the future.
Yes.
Yeah. What are your couple of questions about your service area and your students? What is your service area? Are you located in a city?
Well, we're located in the capital of Delaware, which is Dover, Delaware, and we have basically 3 campuses. One's in each county. There's 3 counties in Delaware, and we're in the middle county, essentially. Our demographics is kind of rural, not real big inner city. The capital city is not a gigantic capital city like other states. So we have pretty much our industry in that area is like craft industries is there. Medium-sized construction or manufacturing plants are there. We have ILC, which is the one that makes the spacesuits, are there in that area. So it's not heavily up north in our Newcastle County is higher amount, but we have another campus up there supplying that. So we essentially supply the whole, student count for the whole state. We're now centralized because we have the most support lab-wise at the center county. So the 2 other campuses, the students come up to, they can take their electives and that type of courses at those campuses, but then they come up to or go down to Dover for the core energy and BS courses.
So you're really pulling students from all 3 counties.
Yes.
And you're serving industries in all 3 counties.
Yes. Our students are varying from somebody who's been out in the field and working in the, say, construction industry for, 10 to 15 years or whatever. And then we have somebody coming right out of high school. So we have a large diversity of, experience coming into the classroom. The process we use is we start out, like I said, with the course that gives them a familiarity of the building systems and grow upon it. So it's a growing type of a program that we go through. Some students do struggle a lot with understanding the principles, but we feel that those principles have to be taught because in order to understand how the functional, look at a commercial HVAC system, you kind of have to understand how it was designed, and you're going to have to understand the principles of what was designed from. So if you don't understand those, it's going to be very hard to see a system after it's running and understand how to fix it or actually how to change, do any work on it.
Yeah. How do you address those students who are underprepared academically? How do you support them?
Well, we have a lot of hands-on lab that we work through. If a student is is weak in, say, electrical side or that type of thing, they can come in for extra help and come in and get a better understanding on, what's going on in that area. We help out in all those ways, and we customize our program a little bit for our students. In other words, we have, like I said, some students are coming in from industry that work during the day. So I'm teaching courses in the evening that I might have taught during the day the semester before. I mean, we're very flexible on whatever the student population needs, we go and provide the course program to fit their schedule. And more so them fitting our schedule. So, we're very accommodating in that aspect. It's a little harder for the instructor because, some days are long and then you might teach a course until like 10 o'clock at night and come back in at 8 o'clock the next morning. But again, I'm doing this more for payback than it is for monetary gain. So we have 4 commercial air handlers, vertical stacked, 2 horizontals, and 1 that's strictly bare VAVs. We have, on the 4 air handlers, we probably have about 15 VAVs off those. 1 is a constant volume unit, and we have a condenser boiler, a air-cooled chiller outdoors, indoors a water-cooled chiller, and a small water-cooled but full-size air-cooled chiller. That's all in the lab, and then also small residential type HVAC systems too for some of that, and then various controls.
And that's in the
BAS.
BAS, and you're using ALC or which control?
We have Tracer, we have ALC, and we also have Contemporary.
Contemporary controls?
Mm-hmm.
Uh-huh. And then what about the energy management? What does that lab look like?
That's about the same size, a little bit bigger in that ballpark. It has all the lighting controls, lighting systems, and we have basically the solar side, the renewable energy side in there. Kind of share that with the renewable energy people. We have it can be 2 labs, but we have it open basically to do both side of it. And we also are introducing home automation in there. That's one of our, I'm pushing that, and I'll have that out this fall, but it's using commercial home automation systems in one of our earlier first courses or so to get the seed started on how to think automation-wise. So I have a lighting control with proximity sensors, and I have it set up like a kitchen, dining room, bathroom, living room, bedroom, and garage. And we kind of work that as a, how all systems work with a voice-commanded Google or Alexa system and different equipment. A lot of our energy management items are basically measuring different energies. So pretty much now you can get commercial, smart plugs that basically give you feedback on how many, historical, how many watts and how many kilowatt hours that the appliance is using, that type of thing. So we have those spread out all over the place, and not only just in the lab, but the whole buildings are lab in their world.
Right.
We use the whole building as the whole campus buildings are basically as their lab.
Yeah.
You have to do certain amount of lecture, but then they need to reinforce that with actual hands-on. The hands-on doesn't mean that they're, wiring up things or that type, really physically. Hands-on, I mean, is actually using the devices, being an operator of the device. just sitting there and, programming something at a laptop as being hands-on on using the program. So, and creating up, that type of thing. So it doesn't mean that they have to be with a tool bag, but they actually see the equipment and they can know what it looks like. They know basically different, we lecture about it, and then they can go out and actually see it, use it, program it, kick the tires. Well, and I think our industry is turning into become more a problem-solving thing than just turning wrenches. I mean, we have enough of contractors that will install equipment and stuff. We don't have the troubleshooting skills to fix the problem when it doesn't work, or fix it before it doesn't work. That's what we're trying to, that group in there. If you want to just become a mechanic, that's different. We don't really do that. We're doing more, teaching troubleshooting.
Yeah.
And that's a hard thing to teach because you got to experience it. You got to think on the fly, and you have to, change your direction midstream 4 times before you get to the end. It might not be the exact direction you're going to go. So it takes that time of mental thought. It's not this cookbook where, we're going to take a trip to California. Okay, we're going to go Route 80 or whatever and go down the road. You might have to detour 4 times before you get there.